Good morning. The date is Friday, February 16th, 2018. It is 10:10 a.m. I regret that I'm not feeling well today, so I am not going to be in class. I can take questions. If you would, if I have anybody, I don't see anybody else in the meeting, but if I do pick up anyone else, you can ask questions. I am also available on Canvas messaging. Today I'm going to continue with Module 5, I believe it is. And let me get this screen shared. Share the screen. Okay, we'll get it in a minute. There we go. Now you should be seeing the screen. And with no further ado, I will shift over to my SQL Server. You should have this file available to you. If it should be attached to an announcement saying what day it is. And in this particular module, we are now get the modules. I'm going to go to the modules now. In the announcements, I give you the file. Let me pick one of these and go to it. So I'm now looking at the modules. Unfortunately, I have a slow computer because the one I generally use is in the shop with getting a new battery. And we are in Module 6, which is Chapter 4. And we are in the second piece of this called the outer join, which is what I'm talking about today. There is a quiz, and I have given you that. Let's see, we do have test 1 coming up. I'm not quite ready for it yet, but I am going to go ahead and post the, or assign the practice test. Test 1 practice test has some points on it. It's worth something. I will give you the solutions to it, so I'll leave it out there for a few days, I guess. It's not worth a whole lot of points, but you should do it anyway. And so you get the points if you do it, and then I'll give you the solutions. Once I post the solutions, I'm not going to accept any more practice tests, but it's not a very big deal. I think it's only 10 points or something like that. Introduction to the outer join. I'm going to go back and introduce that from here. We have seen the inner join. Okay, inner join, joining two tables, and most of the time it makes the most sense to join tables on a foreign key, primary key pair. Yes, they can be. We saw an example, for example, where Vendor City was joined on to Vendor City, the vendors were joined to themselves. Clearly that was not a primary key, foreign key, but most of the time, 99% of the time, a join is following a foreign key to a primary key or vice versa. Example of the inner join here. Select vendor name, invoice number pairs from vendors as the inner join invoices. And I do want to, I will reiterate here, I do want to see the word inner used in there. Don't just say join, please. In the inner join, the order of the tables is irrelevant. So which one of these in the from line you decide to put first is your own business. It really doesn't matter. If you have more than two tables, it does matter which of the three tables you are joining. So if I have table A joined to table B, joined to table C, if I switch A and B, it wouldn't hurt anything. But if I switched A and C, that would be a different animal. Okay, inner join, the order of the tables, it doesn't matter. So here I've turned it around. you can reverse the lines without hurting anything. I believe I said here, I generally put the parent table first. That's just my convention. I suggest you have some convention, either put the child table first or the parent table first, and just do it that way all the time. Since it doesn't matter, I'm not going to enforce that. Here it is backwards. Switching the order of the tables might cause the order of the rows to change, but I don't have an order by clause. If I don't have an order by clause, then clearly I can't care because I don't know what order I'm going to. I only get an order when I put this order by something. So if I said order by vendor name, I'm going to get the same order either way. Okay, here's the important property of the inner join. It will only return rows that participate in the relationship. An inner join is useless for finding orphans. Well, I guess you can find orphans from an inner join, because the only thing I have to know for an orphan is, I would not find an orphan from an inner join. I don't need a table join to find an orphan. I just search the table for a null foreign key. So I only need one table to find an orphan. Inner join will not return orphans. An inner join does not return childless parents, and an inner join does not return invalid foreign keys. Those are the three things to remember. Now for these, we need the outer join. And that's the topic for today, is we're going to be talking about the outer join. Consider the following hypothetical table join. Select vendors, some kind of join, invoices. Now, I'm just making that up. But I wanted to demonstrate that as a read across, I have one of these that is on the left side and one of these that is on the right side. I don't know which one's going to be which. And I said that in the, excuse me just a minute. Not feeling really great today. I said that in the inner join it didn't make any difference. In the outer join it is going to make a little bit of difference, because we have one on the left and the one on the right. And thus the query, select vendor name, invoice number from vendors as V, left outer join. So notice that this one is pointing at the vendor's table. The one on the left is the vendor's table. Invoices as I. There's the primary key, foreign key. Similarly to an inner join, the outer join follows a primary key, foreign key, usually. This join will return all rows from the vendor's table, as well as matched invoice numbers from the invoice table. So whichever way it's pointing, this one's pointing left to the vendor's table, it's going to give you all rows from this table unless you filter them with a where clause. If you run this query, look at the output, you will see that the unmatched records will simply have a null invoice number, and we're going to see a bunch of them. So if we run this, you will have to go up and run your use first. I've already done that, so I can execute it. And notice I got 302 rows. And I have more unmatched records than I have matched records. I start getting a few of them. I think I've only got 30 or 40 that are actually matched. More of my vendors do not have any invoices than do. Okay. Let's see. Try to keep my eye on the, okay, I see. Okay, I'll come back to that. We'll return all rows from the vendor's table. Okay, now very likely if the invoice number is going to be null on all of these, so if I have a childless parent, they get to be a childless parent because they don't have any invoice numbers. Their primary key never appears as a foreign key in the invoices table. Therefore, this invoice number is just going to be null for all of them that I want. So I really don't need to show that, to return that bunch of nulls. And the where, I'm really not interested in seeing anything except where this guy is null. Remember, I'm going to see them all. So if all I do is run this, I'm going to see all of the vendor names. But I'm only interested in vendor names where the vendor ID is null. Actually, the invoice number would also be null, but it's better to use the primary key. So this is the invoices. Invoices primary key is null, where vendor ID is null. And this is only going to give me, if I run this, I will only get the vendors that do not have invoices associated with them. I don't remember how many there are. I can run it and see what I get. 89 rows. So I have 89 vendors that are childless. One other little point here is sometimes I will go in and, shall we say, mess with the data. And I believe I've changed the data a little bit since I wrote the exercises. So if your data are off by 1 or 2, and you feel good about it, don't worry about it. It's I'll try to get in there and get those cleaned up. I need to go through the whole deal. It takes a lot of work to do that because there are so many little details to fix on it. So if I change the data a little bit, for example, well, we're going to find that I added a invalid foreign key to the to the invoices table. Let me proceed here. I'm seeing 89 childless parents. If you see 1 or 2 more, it could just be that your data are slightly different from mine. Notice that like its cousin, the inner join, the order of the tables may be reversed, but you have to reverse the direction of the outer join. Okay, so I'm going to rewrite the above query. Notice this time I've changed the order of the invoices. I put the invoices on the left, the vendors on the right. And since I'm still wanting everything from vendors, I changed the direction of the query to the right outer join. I refer typically to this table. When I do it a lot, I will call this table the upstream table and this table the downstream table. I don't know whether people do that or not, but so this one takes everything from the upstream table, the table to which it points. So I'm saying right, that means look on the right, and you're going to take everything from that table. But I'm going to, after I take everything in the from line, in the where line, I'm going to pare it down, and I'm going to say I'm only show me those where the invoice with vendor ID and the invoices is null. This will have the same output as the query above, up to order. For this reason, some platforms only support the left outer join. I don't see very many of these anymore. MySQL, the open source database, very good database, did not used to have a right outer join. They just had an outer join. And you had to put the downstream, the upstream table, you just had to put it on the left. Mentioning syntax here. Remember that I don't like it this way, but sometimes at least the author of our slides, our PowerPoint slides, will frequently write an inner join where the from line looks something like this. From invoices as I, join vendors as V. This is not good practice in my opinion. And you should say inner join. Not all database products support dropping the word inner. Most of them do today, I think. I haven't seen any in a long time that would have a problem with it if you just said join. But nonetheless, I'm teaching the full syntax. Also, they will frequently drop the as. So invoices space I, join, vendors space V. I don't, you can drop too much. Our PowerPoint slides do that. Not in this class, not on my watch, please. We're going to keep the full syntax. Okay, outer join can also be also has an abbreviated syntax, and we can drop the word outer. For example, you can just say left join and right join, but you can't do it in this class and not get full credit. I have said enough about that. So the full syntax is left inner join or right inner join. Excuse me, I'm sorry, strike that. Left outer join or right outer join, and the inner join is just inner join. Okay, here's a question. Are there any invalid foreign keys in the invoices table? So we have found childless parents. Let's go in here and find if there are any invalid foreign keys. Now I happen to know that there are because I put them in there. To answer this question, that's probably why you're off by 1 or 2 in some of your queries, where your queries are perfectly okay. I think I went in and added some invalid foreign keys to some of the tables, and they will probably pop back from some of your queries, particularly if you're doing them, if you don't have a join in them. You need all of the rows from the invoices table. Therefore, the outer join will have to point. So the invoices table is the upstream table. And here I have the query, select vendor name, invoice number. I have notice that the invoices is upstream. So the invoices is, the query points left, invoices is on the left. Could have accomplished the same thing by making it point right and put the invoices table on the right. It would have been exactly the same query. There's the primary key, foreign key, taking a left outer join, find everything, give me everything from invoices. Now, if you do this, you'll get a whole bunch of stuff, and there will be one. I think it's down there at towards the very end, if it's unsorted, and the invoice number is MAB. I believe that's O, MABO, I don't know, 1489. It is associated with a null vendor name. However, we have a whole stack of stuff in there, but it means that this value is in the invoices table. However, this value, and it references an invalid primary key in the vendors table. And I put the sign there. This is very bad indeed. To do this, I disabled the foreign key constraint in invoices, and then I put the invalid data in there and turned it back on. Now, what am I really interested in here? Probably, I don't really care what that number is. It's invalid. I don't have a primary key. I don't have a parent by that number. So the thing I'm probably interested in here is the invoice ID. Remember, the invoice ID is guaranteed to be unique. The invoice number is not, although it probably will be. It's not the primary key, and if I get the primary key of that table, then I will be able to act on it much better. So I'm interested in the invoice ID. I need the vendors table in the query because I want the null value, but I'm only going to take data from the invoices table. So in all its glory, here is the query. Select invoice ID, and I'm throwing in the invoice number. I didn't really need that. It's just that's the invalid invoice number. But I'm mostly interested in this invoice ID from invoices as I, left outer join, invoices is upstream, vendors as V, where the primary key matches the foreign key, on that anyway, where the vendor ID from the vendors table is null. Now you're going to find that, what will you find? If I execute that, I should get one record, execute, and I have invoice ID 68. It looks like an O instead of a 0. But invoice ID 68 would really be better. Because I just, we might use that later, so don't delete it. But I now know which record it is that's giving me the problem, that ID number 68. It is the last one. And if I were managing this as a working database, I would address this one as quickly as possible. I do have several options on what I might do. I'm saying we'll just leave it there in this database. I could delete the record. I don't really want to do that though, because I just hate to, very seldom, believe it or not, very seldom do you ever delete data from a database. It is almost never done. Like I say, that's deleting a record is drastic. Set the foreign key to null. Okay, well, that's a little bit better than just throwing the data away, but it might be constrained. There might be a reason I can't make it null. Even if it's constrained, I could go in, release the constraint, and then put null in there, and then turn the constraint back on. But I'd still have something that didn't quite jibe. I don't like that, but I might do it. And here's the preferred approach. I would put into the vendors table, if I can do this. This is one I'm going to choose. I'll put something into the vendors table where he has a dummy primary key. I'm going to make up the record. I'm going to call him the parent of orphans and invalid data, whatever. And what I would do would be I would put his primary key as the foreign key of the invalid record. And then at least I would have, I still don't know what to do with the data, but at least I have it and my data are now consistent. So that would be my first choice. Okay. Summarizing. Inner join only returns related records. Let's see. Terms used frequently. Here's where I talk about upstream and downstream. Remember an outer join, this only makes sense on an outer join. So if it's a left outer join, the table on the left is upstream, the table on the right is downstream. If it's a right outer join, the right side, the table to the right side is upstream, the table left is the downstream table. We're going to get everything from the table in the direction that this guy points. That's why I'm calling him upstream. Everything comes from the upstream, downstream. So right, we'll take everything from the right table. Keep wanting to ask if there's questions, but I don't think I have anybody in the meeting at this time. Notice that it points at the upstream table. So I use that terminology. Thus, an outer join returns all rows from the upstream table, whether they match or not. There's one other form, it's called the full outer join. Full outer join returns all rows from both tables. I'm not going to cover that one a whole lot. First of all, it's not very useful, and it's not supported in a lot of platforms. And if I took a left outer join and followed it by a right outer join and then put them together into one data set, I've got exactly the same thing. So, and suppress duplicates, I would have exactly the same thing. So I won't talk about that any further. And I believe that's the end of my slides that I had set out to do. I usually get through it a little bit faster when I don't have a live audience. And I see a misspelling there. Make a note of that because you might have seen textbook. I will take questions on this in the Canvas messaging. So at this point, I'm going to go ahead and end the recording. And I will cover this again in class. I'm going to go ahead and make the, I'm going to assign the practice test 1. You will find the practice test 1 to be an awful lot like the actual test 1. And we'll talk more about the actual date and time of it. I don't just turn it on and leave it on for a week. So you'll need to schedule the time when you do it. Usually I put a time constraint on it, and but I let you start it anytime you want to. Okay. I'll talk more about that guy as we go. Okay, so the assignment for Module 5, both assignments for Module 5 together are worth 40 points. They're worth 20 points each. Half of it's inner join, the other half of it's outer join. And I guess I'll see any questions over in the I'm gonna go ahead and end the meeting right now. I see my wife is waving at me for something. So I will get this posted as quickly as I can.